Okay, guys, now let's have a look at the fourth question of today's contest. The fourth question was find edges in shortest path. What does the question say? Let me explain you the question in short. We are given with the nodes which are numbered from 0 to n minus 1. It means the graph is following a zero-based indexing. We are also provided with a 2D array edges. What does the array edges represent? It represents an edge from AI to BI with a weight of WI. So we are given with three parameters and every edge is at the index of I, AI, BI, WI. What does it mean? That there is an edge connecting AI to BI with a cost of WI. And in the similar way, there is an edge connecting BI to AI with a cost of WI, since it is an undirected graph. What we need to do is we need to consider all the shortest paths which are from node 0 to node n minus 1 in the graph. So what do I mean by shortest path? Suppose if I want to travel from 0 to n minus 1, the minimum distance that I need to travel is 5. So there can be multiple ways to reach to that particular distance. For example, see in example number 1. The nodes are numbered from 0 to 5. I need to travel from 0 to 5. So what is the minimum cost that I need to travel from 0 to 5? The minimum cost is 5. There can be no other cost which is lesser than 5 if I want to reach from 0 to 5. But there can be multiple ways to reach 5 from 0 by traveling a distance of 5. See, if I go from 0 to 1 and then from 1 to 5, what is the distance? 4 plus 1. In the similar way, if I go from 0 to 2, 2 to 3, 3 to 5, what is the distance? 1 plus 1 plus 3. In the similar way, if I go from 0 to 2, 2 to 3, 3 to 1, and 1 to 5, what is the distance? 1 plus 1 plus 2 plus 1, which is again 5. So there are three ways to reach from 0 to 5 by traveling the minimum distance. So to travel the minimum value is only 1, but there can be multiple paths. So what we need to do is we need to consider all the shortest paths which are required to travel from node 0 to node n minus 1. Now I need to make one Boolean array answer which I need to return. If that particular edge is a part of any of the shortest path, if that particular edge is part of any of the shortest path, then I need to update the value of my Boolean array answer to true. Otherwise, I need to update it to false. And at the end, I need to return the array answer. So I hope the question is clear to you all. What we are doing is we need to consider all the shortest paths from node 0 to node n minus 1. And if any edge is part of any of the particular shortest path, we need to update the value to true. Otherwise, we need to update the value to false. Now, what is the approach that we are going to follow? First of all, whenever the shortest path comes in a question of graphs, the very first thing which clicks in our mind is Dijkstra's algorithm. So here also we are going to apply the Dijkstra's algorithm. But what is the twist is we are going to apply Dijkstra's algorithm in two directions. What do I mean by it? Just see. Suppose I want to find whether 0 to 1 is a part of that shortest path or not. What will I do? I will calculate the distance from the source node. What is the source node? The source node is 0. I will calculate the distance of the source node to this particular node, that is 0 to 0. The distance is 0. As well as I will calculate the distance from the destination node, that is 5 to 0. For each and every node, I will calculate two distances. So the very first distance will be from the distance from the source node to that particular node. And the second will be the minimum distance from the destination node to that particular node. In an edge, there are always two nodes. So if distance from 0 to 0 plus distance from 1 to destination plus that particular edge weight gives me the shortest value which I need to find in order to reach from source to destination. I repeat. In this particular example, if I want to travel from 0 to 5, the minimum distance is 5. So if from this source to node 0 plus destination to node 1 plus this particular edge, if the sum of all these three things comes out to be that shortest path, that is shortest value, that is 5, So it means it is a part of that particular shortest path. Otherwise, it is not a part of that. Let me do the dry run. The minimum value is 5. So for distance from source to this 0 will be 0. Distance from 1 to this 5 will be 1. And this weight is 4. So 4 plus 1 gives us 5. It means 0 to 1 is a part of the shortest path. I will update the value to. So 0 to 1, true. Next, let me see 1 to 4. What is the shortest path to reach from node 0 to node 1? It is 4. What is the shortest minimum distance that I need to reach from destination node to node 4? It is 2. So 4 plus 2 comes out to be 6. 6 plus 3 gives us 9. It means that 9 is not equal to 5. It means 1 to 4. This particular edge is not a part of any of the shortest one. So I will update the value to false. See 1 to 4. 1 to 4 was here. And we have updated the value to false. So this is the thing which we are going to do. What we will do is we will apply Dijkstra's 2 times. One time we will find the minimum distance to reach a particular node from node 0. Second time we will find the minimum distance to reach a particular node from the destination node. And at the end we will check. From the code, it will give you much more clarity. See, what we did is, first of all, we have made one adjacency list. We have resized it to 10. And why? Because it is following a zero-based indexing. Then I have inserted, we made one res vector, a result Boolean vector, which we will return at the end. And first of all, I have initialized all the values to false. So here I have made my adjacency list that adj at the index of u dot pushback v comma weight, adj at the index of v dot pushback u comma weight. This is very much clear to everyone who has studied graphs. Now, this is the main thing. I have made one vector d1, which will help me storing the minimum distance from the source node to that particular node. And initially, I have given it a very big value, that is e raised to the power minus 12, 10 raised to the power 12. D2 will store the minimum distance from the destination to node to that particular node. Whenever we apply the Dijkstra's algorithm, we made min heaps. So I have made 2 min heaps since I am applying Dijkstra's in 2 directions. I have pushed back pq1.push 0, 0. Since to reach node 0 from 0th node, the distance required is 0. And I have updated d1 at the index of 0 to 0. While not equal to pq1.empty, this now I have applied the simple Dijkstra's. And in this, my d1 array is getting updated. So I hope this is clear to everyone. In the similar way, I have applied Dijkstra's for the destination one. So if I want to reach my destination node to destination node, that is, if I want to reach 5 to 5, the distance required is 0. So d2 and minus 1 is 0. Now in my d2 vector, what will get stored? It will store the minimum distances that are required to reach from the destination node to that particular. So I have applied the Dijkstra's second. So d1 array is storing the minimum distance to travel from the source node to that particular node. D2 vector is storing the minimum distance that we need to travel from the destination node to that particular node. Now this is the main, in which we are updating my result vector. If D1 at the index of u, that is my first node, plus D2 at the index of v plus weight, gives me D1 at the index of n minus 1. What is this D1 at the index of n minus 1? This is the minimum distance that is required to travel from the node 0 to node n minus 1. If this condition is satisfied, it means that particular edge is a part of the shortest path. So I will update it to 2. Or D1 at the index of v plus D2 at the index of u plus weight gives me that particular shortest value. So then also I will update it to 2. We have done nothing. Let me explain you my approach in short one more time. What we have done is simply we have calculated for each and every node the minimum distance that will be required to travel from the source node to that particular node. As well as we have calculated in my D2 vector the minimum value that we require to travel from a destination node to that particular node. If these two distances plus the weight which is connecting these two edges gives me that shortest value, it means that particular edge is a part of the shortest path, otherwise it is not. So initially I have updated my result to false. If none of these two conditions are satisfied, it will remain false. Otherwise, it will get updated to true. So I hope the question is clear to you all. In case the question is clear, don't forget to subscribe to our channel and share it with your friends. Thank you.